Has there been a significant change in the opinions about affirmative action regarding women in the past decade? The GSS presented people with the following statement. Because of past discrimination, employers should make special efforts to hire and promote qualified women. In 2000, 514 out of 791 respondents said they agreed or strongly agreed with this statement. We will call this Group 1. In 2010, 458 out of 696 respondents said the same. We will call this Group 2. Is there a significant difference between the proportion of Americans that agreed or strongly agreed in 2000 and 2010? I've highlighted some important information from the problem that we will be using to solve this problem. First of all is the proportion from the sample from the year 2000, 514 out of 791, and they've indicated that we will call this Group 1. And then the sample for the second proportion from 2010 is 458 out of 696, and they indicated we would call that Group 2. And then also we need to know exactly what we're testing for the alternative hypothesis, and it says we are testing that there is a significant difference between the two proportions. So we're going to be using the two-sided not equal to symbol. Here I've shown the calculation of the two sample proportions. The sample proportion for population 1 is 0.6498, and the sample proportion p hat 2 for population 2 is 0.6580. The assumptions for using this test is that we have qualitative data for two groups, and it was qualitative data. We were the proportion who said they agreed or strongly agreed, and then the people who did not say that. So basically it was like a yes or no type of thing. Yes, they said strongly agreed or agreed, or no, they did not say those. We do have independent samples. It said so in the problem, and we do have very large sample sizes. So we're good on all of our assumptions. Here's what we have stated for our hypotheses. Population 1, the proportion for population 1 equals the proportion for population 2, and our alternative is that the proportion for population 1 does not equal the proportion for population 2. And now we're going to turn to StatCrunch to find the test statistic and p-value. We're going to click on Stat, Proportion Stats. This time we do have two samples, and we have the summary data. So the number of successes for the first sample is 514 out of 791. The second sample is 458 out of 696. We're doing a hypothesis test. We are testing that the two proportions are equal. So that would mean their difference would be 0 versus not equal. So we leave that as the default not equal to symbol, and we click on Compute. And here we have our test statistic, negative 0.333, and our p-value 0.7391. So I've pasted that information here into my document. Again, there's the Z test statistic and the p-value, and that is a very large p-value. So we are not going to be rejecting HO in this case. Remember, very small p-values lead us to reject HO. Well, this is very large, so we are going to not reject HO. So our conclusion could be something along the lines of, based on a p-value of 0.7391, we do not have statistically significant evidence to say that there is a difference in the proportion of opinions of all Americans about affirmative action regarding women in 2000 and 2010. Now let's look at a 95% confidence interval. Going back to StatCrunch and my output, I can click on Options, Edit, and the only thing I'm going to do is change the option here to perform a hypothesis test down to performing a confidence interval. I'm going to do a 95% confidence interval, so I'll leave that as the default. Click on Compute, and here I have my 95% confidence interval down here on the end of my output. You'll see that this is the confidence interval, and since 0 is a part of the confidence interval, it is plausible, based on the confidence interval also, that there is no difference between the population proportions. And since we're doing proportion 1 minus proportion 2, whenever we have a negative here, our lower limit is negative. P1 minus P2, when it's negative, that indicates that P2 was larger. We were subtracting a larger number. That's what gives you a negative answer. So that would indicate that the proportion in 2010 is larger, and it would be larger by 5.7%. And here we have a positive end of our confidence interval. When it's positive, and since we're doing the subtraction here, that would indicate that proportion 1 is larger, and that's the proportion from 2000. So that proportion, the proportion from 2000 is 4% larger. So, based on this interval, it is plausible that the proportion, true proportion could be 0, or it could be that proportion 1 is larger by 4%, or that proportion 2 is larger by 5.7%. So here's what a confidence interval conclusion would look like. I do want to point out that when you do have this situation where you have one that's negative and one that's positive, it is a little bit more confusing to interpret that. We can be 95% confident that the proportion of all Americans who agreed or strongly agreed with the following statement: because of past discrimination, employers should make special efforts to hire and promote qualified women, in 2000 and 2010 was between 4% higher in the year 2000 to 5.7% higher in the year 2010. Since the interval contains the value of 0, it is plausible that there is no difference between the proportions from 2000 and 2010.